Hello Legacy students, Marsh here. So today we're going to talk about trigonometry. What you're going to want to have on you, a scientific calculator. Can't be a normal calculator, has to be scientific. Pen or pencil, foldable that I gave you in class, the purple one. And then also your notebooks. We're going to take an example outside of the foldable. What is trigonometry used for? Basically, it was math that was once used to find the distance that could not be measured physically. So basically, from here to the moon, trigonometry was used to get that distance that we can't physically with a ruler or any other kind of measuring tool be able to use. So what does trigonometry mean? Basically, it's Greek for measurements of triangles. It can only be used on right triangles, and we're going to be using some new buttons on calculators. You may have seen them before, the SIN, COS, and the TAN button. If you have a Texas Instruments calculator, one thing you're definitely going to want to find is the sine button, the cosine button, and the tangent button. Other thing you're going to need to also look at is see in the corner right here if it says RAD. If it says RAD, you need to tell me now when we get back to class, and then I will convert it back into a different method. Otherwise, all the answers you're going to get in class are going to be wrong because all it is your calculator's in the wrong form. So let me know if your calculator that you normally use says RAD in the corner. Let me know and I will make sure that that gets fixed for you. Also, calculator on, like, let's say an iPhone, same thing, sine, cosine, and tangent button. Same thing though. If you have RAD in the corner, that's not good. What you're going to want to push is the DEG button over here. That would get you into what's known as degree mode. Otherwise, you'll be in radians mode, which you'll deal with in Algebra 2 and also pre-calc as well. So you're going to want to be in degree mode, not in RAD radians mode. Alright, so let's talk about some parts of a right triangle that we're going to be using quite a bit in trigonometry. So you guys already know this angle right here. This is your right angle. This guy right here, this guy is known as theta. In case you ever see that word again, it looks kind of like an 8, but it's a theta. You guys already know the name of this side of the right triangle because it's across from the right angle, so you guys know this guy is the hypotenuse. Now, there's some other things we're going to need to talk about side lengths. Let's imagine I have a little guy standing right over here, and if he had to walk across the entire side of this triangle to get to the other side, this is what's known as the opposite side of a triangle. So basically it's completely all the way across from the angle. The other side that is on a right triangle that we're going to be kind of using in trigonometry is what's known as the adjacent side. So basically next door, if you want to consider it that way. That would be next door to the angle that we're talking about. Now go ahead and grab out that foldable that we cut together in class today and open up the first tab, the sine tab. So sine, guys, sine angles are when you have an opposite side over hypotenuse side. So up here, if you want to make a little note also, a good way to remember this is so sine is opposite over hypotenuse. Now let's go ahead and figure out, based on an angle, what would that ratio or that fraction be? So let's say I want to find the sine of angle A. Well, first of all, I need to find the opposite side, which means I have to run all the way across this triangle here. This would be my opposite side. So that would be 12 over the hypotenuse, which is across from the right angle, so this guy would be my hypotenuse. So 12 over 13 would be the ratio there. Now let's say I want to find sine of B. You know what? I bet our opposite side's going to change, because if I'm looking for the opposite of this angle, I got to go across the way, all the way to 5. So this would be my opposite side, 5, over my hypotenuse, which is 13. In this case, the 12 side would be the adjacent side to B, which we'll use a little bit more once we get to cosine. Now, let's try an example with sine. I got my angle here, 50 degrees, and let's go ahead and label the sides. So if I got my little guy standing right here, across the way, this has got to be my opposite side. Across the way there is my hypotenuse. So this guy's got to be the adjacent side because I haven't labeled it yet. So I know that the sine of 50 degrees is equal to 50, because that's my opposite, over x. Now, what's cool about this is it's going to allow me to solve for that missing side of my triangle. But first, I want to know what is the sine of 50 degrees. So on my calculator, I am going to go to push the sine button, and then 50, and push equals. I get a decimal of 0.7660. That is me rounding a little, rounding to 4 decimal places. And I know that's equal to 50 over x. X is in the denominator. So you know what I'm going to do? I'm going to make this a fraction. This might make it a little easier. Now I can just kind of cross multiply, just like we were doing a unit ago. So I'll get 0.7660x equals 50. It looks like I need to divide by that decimal there. So I'm going to get x equals, what is 50 divided by 0.7660? I get a decimal of 65.27 for an answer. So that would be the length of my hypotenuse in that particular triangle. Now, let's go down to cosine. So cosine, guys, a good way to remember cosine is the adjacent over the hypotenuse. So not the opposite like sine, but the adjacent. Now, some people remember him as the ka of our so. So and ka are sine and cosine. Good ways to remember it. Now, let's go ahead and find the cosine of our A side. So I know, guys, over here, this guy's the opposite side. I know this guy's got to be the hypotenuse, so the side I have marked in, that's the adjacent side. I usually mark in the adjacent after I marked in my opposite and my hypotenuse. That way I make sure I don't kind of screw up the opposite and the adjacent sides. So I know, since it's adjacent over hypotenuse, the cosine of A would be 5 over 13. Okay? Now let's find the cosine of B this time. Now notice, guys, just like last time, the opposite of B will be 5. So this guy's got to be the adjacent to B now. So I would have 12 over 13 for the cosine of B. And yes, you're very right. The sine of B was the cosine of A. It's kind of a little screwed up at times. But the cosine is the adjacent over the hypotenuse. Now let's try to actually solve that in a particular problem here. So I have an angle here, 53 degrees, and I know this side's 45, this side's K, so I want to find this side. So let's mark in all of our sides. So I got my guy standing right here. Cross the triangle, this is my opposite side. Crossing the right angle is my hypotenuse, so this guy's got to be the adjacent. So notice, guys, I have something on the side of A and something on the side of H. So I need to use cosine because A and H are in the cosine problem. So I'm going to have cosine of my angle, which is 53 degrees, equals my A over my H, 45 over K. I need to get a number here for cosine of 53. which after I typed into my calculator here, I get 0.6018 equals 45 over k. Let's put that over 1 again. Do some cross multiplying here. K equals 45. Looks like to divide, I gotta divide because I gotta get k alone. Now let's divide that. 45 divided by 0.6018. That would be for k, I will have 74.78 if I round. So my hypotenuse of this particular triangle is 74.78. Let's talk about the last trig ratio that you can use, called tangent. Tangent is opposite over adjacent. So a lot of people like to remind them or remember this as the TOA. You may have heard SOHCAHTOA before. That's a good way to remember the trig ratios in your head. That way you don't have to memorize opposite over adjacent. You just remember SOHCAHTOA. But let's go ahead here, guys, and find the tangent of angle A. So this guy right here. Let's mark in all of our sides. Well, I know across from A, this guy's got to be O. Across from here, here's the hypotenuse. So this guy's got to be the adjacent side. So the tangent of A, its ratio would be 12 over 5. Let's now find the tangent of B. So this angle here, so opposite of B, that would be this side now. Hypotenuse is still there, so this guy's got to be the adjacent side. So the tangent of B would be 5 over 12. So basically the reciprocal of tangent of A, kind of different there. Let's now try the example here. So I got an angle of 30 degrees. So let's go ahead and mark in our sides. So if I got my guy standing right here, this has got to be the opposite side. Across from the right angle, this is the hypotenuse. So this guy's got to be the adjacent. Notice I have stuff on the O and the A side. So I have tangent of 30 degrees equals n over 25. So tangent of 30 degrees, let's actually get a decimal for that. That is 0.5774 equals n over 25. Let's go ahead and cross multiply here. So I get 0, or let's figure out what 5.774 times 25 is. And I get 14.44 equals 1 times n, so n. And look, guys, n's already solved for. So my answer to this side length of my triangle is 14.44. Now, let's try a problem that's not in the foldable. This guy is a little bit more. Notice we're solving for two sides. We're going to have to use a couple of the trig ratios to solve this. So we have an angle here. It's 48 degrees. Let's mark in our sides. Which one's the opposite? Which one's the hypotenuse? So across the way, this guy's got to be my opposite side. Across from the right angle, he's got to be the hypotenuse, which means this guy's got to be the adjacent. Now notice, guys, I do not want to use sine, because sine would be O over H, which would both be X and Y. Not going to work. So I need to use something that doesn't use the O and the H. So let's first use O and A. So if I remember my SOHCAHTOA, which one had an O and an A in it? Well, this one has an O and an H. Not working. I think I have to use tangent for this first one. So I'm going to go tangent of 48 equals my O, which is X, over A, which is 8. So I need to know first now what's the tangent of 48, which my calculator tells me is 1.1106 equals X over 8. Let's cross multiply here. So 1.1106 times 8 is 8.88. So 888 equals x. So I actually now have found that side length. Now, we don't want to reuse that side length because it's kind of rounded. There's some rounding in there, which will mean our y value, if we would use it in there, wouldn't work. So now instead of using our O and our A, let's use our A and our H. So which one of our trig ratios is going to get us the answer? Well, we can't use the O over the H. Let's use the A over the H. So cosine. So cosine of 48 is got to equal 8, my A, over my H, which is y. So I need cosine of 48, which my calculator tells me is 0.6691. That's 8 over y. Do some cross multiplying here. I'm going to move over to the side. 0.6691 y equals 8. Looks like I have to divide to get y alone this time. So I get 8 divided by 0.6691. So I get for our measurement for y to be y equals 11.96. And that's the end of this video. See you later, Sabers.